Hello and welcome to this machine learning course. This is a course for aspiring data scientists and an ML engineer. Okay, so let us look at what machine learning is. So, what is machine learning? Machine learning is about extracting knowledge from data. It is a research field at the intersection of statistics, artificial intelligence, and computer science, and is also known as predictive analytics or statistical learning. Okay, so the application of machine learning methods has in recent years become available everywhere. Okay, so from automatic recommendations of which movies to watch, to what food to order or which products to buy, to personalized music suggestions and recognizing your friends in your photos, many modern websites and devices have machine learning algorithms at their core. Okay, when you look at a complex website like Facebook, Amazon, or Netflix, it is very likely that every part of the site contains multiple machine learning models. Now, why do we need ML? Okay, so why do we need machine learning? In the early days of intelligent applications, many systems used hand-coded rules of if and else decisions to process data or adjust to user input. Okay, so think of a spam filter whose job is to move the appropriate incoming email messages to a spam folder. Okay, you could make up a blacklist of words that would result in an email being marked as a spam. This would be an example of using an expert designed rule system to design an intelligent application. Okay, manually crafting decision rules is feasible for some applications, particularly those in which humans have a good understanding of the process to model. However, hand-coded rules to make decisions has two major disadvantages. One is the logic required to make a decision is specific to a single domain and task, and changing the task even slightly might require you to write the entire system. Okay, and the second thing is designing rules requires a deep understanding of how a decision should be made by a human expert. So one example where this hand-coded approach will fail is in detecting faces in images. Okay, so the problem in which pixels which make up an image in a computer are perceived by the computer is very different from how humans perceive a face. This difference in representation makes it impossible for a human to come up with a good set of rules to describe what constitutes a face in a digital image. But using machine learning, simply presenting a program with a large collection of images is enough for an algorithm to determine what characteristics are needed to identify a face. Okay, so now we'll look at some of the problems that machine learning or ML can solve. Okay, so identifying the zip code from handwritten digits on an envelope. Okay, here the input is a scan of the handwriting and the desired output is the actual digits in the zip code. To create a dataset for building a machine learning model, you need to collect many envelopes. Then you can read the zip codes yourself and store the digits as your desired outcomes. Okay, so the next thing is determining whether tumor is benign based on medical image. So here the input is the image and the output is whether the tumor is benign. To create a data set for building a model, you need a database of medical images. You also need an expert opinion. So a doctor needs to look at all the images and decide which tumors are benign and which are not. It might even be necessary to do additional diagnosis beyond the content of the image to determine whether the tumor in the image is cancerous or not. And then one of the other applications would be detecting fraudulent activity in credit card transaction. Here the input is a record of the credit card transaction and the output is whether it is likely to be fraudulent or not. Assuming that you are the entity distributing the credit cards, collecting a dataset means storing all transactions and recording if a user reports any transaction as fraudulent. Okay, so the another application of machine learning would be identify topics in a set of blog posts. If you have a large collection of text data, you might want to summarize it and find prevalent themes in it. You might not know beforehand what these topics are or how many topics there might be. Therefore, there are no known outputs. But this is an example of unsupervised learning where we'll look into it. What we'll try to understand what supervised and unsupervised machine learning is, and this case is a case of unsupervised learning where we have the inputs but we have no idea about the outputs. Okay, But in the previous examples, for example, the zip code, the tumor thing, and the fraudulent activity, we knew, we had some evidence of the what the outcome looked like. Okay, but when it comes to the identifying topics in a set of blog posts, or segmenting customers in a group based on similar preferences, we have no idea about what the output should look like. Okay, even detecting abnormal access patterns to our website. So these are some of the examples of or problems that machine learning can solve. Okay, so one of the most important thing is of the ML process is knowing your task and your data. So some of the things that you should remember and try to answer while starting or modeling a machine learning is: what questions am I trying to answer? Do I think that data collected can answer the question? Okay. So the next thing is, what is the best way to phrase my question as a machine learning problem? Okay. So the next another important thing we should keep in mind is, have I collected enough data to present the problem I want to solve? So this is very important. And how will I measure success in my application, and how will the ML solution interact with other parts of my business product? So these are some of the things that you need to keep in mind while starting off in the ML process. So let us now look at some of the libraries that we will be using. Okay, so the first thing is scikit-learn. Scikit-learn is an open source project, meaning that it is free to use and distribute, and anyone can easily obtain the source code to see what is going on behind the scenes. The scikit-learn project is constantly being developed and improved, and it has a very active user community. It contains a number of state of the art machine learning algorithms, as well as comprehensive documentation about its algorithm. Scikit-learn is a very popular tool and the most prominent Python library for machine learning. And scikit-learn depends on two other Python packages, numpy and scipy, which we can see here. This numpy and this is scipy. We'll also try and explain what these libraries do. Okay, and so now the next thing that we have is matplotlib. So matplotlib is the primary scientific plotting library in Python. It provides functions for making publication quality visualizations such as line search, histograms, scatter plots, and so on. Visualizing your data and different aspects of your analysis can give you important insights, and we will be using matplotlib for all our visualizations. The next library that we have is pandas. Pandas is a Python library for data wrangling and analysis. It is built around a data structure called the data frame. A pandas data frame is a table similar to an Excel spreadsheet. Pandas provide a great range of methods to modify and operate on this table. In particular, it allows SQL-like queries and joins of tables. In contrast to NumPy, which requires that all entries in an array be of the same type, Pandas allows each column to have a separate type. For example, integers, dates, floating point numbers, and strings. Okay. So the next thing is the next library that we'll be using is the NumPy library. So NumPy is one of the fundamental packages for scientific computing in Python. It contains functionality for multidimensional arrays, high-level mathematical functions such as linear algebra operations, and a Fourier transform, and pseudo-random number generators. Okay. In scikit-learn, the NumPy array is the fundamental data structure. Scikit-learn takes data in the form of NumPy arrays. All elements of the array must be of the same type. It's very important that you remember this. Okay. So the next library that we'll be using is the SciPy library. SciPy is a collection of functions for scientific computing in Python. It provides, among other functionality, advanced linear algebra routines, mathematical function optimization, signal processing, special mathematical functions, and statistical distributions. Scikit-learn draws from SciPy's collection of functions for implementing its algorithms. The next thing that or the last library that we'll be using is the Seaborn library, which is again a data visualization library. Okay, very similar. It is in fact built on top of matplotlib, so it is very similar to this matplotlib, but there are some if we use Seaborn because it makes things easier for us, like for heat maps and other charts, we can use Seaborn to make our job easier. Okay, so I think this is it for this video. In the next video, we will look at how to sort of we'll try to classify. We'll try to basically build our first application, which is classifying iris species. Okay, so we'll look at that, and that is it. So this is it for this video. I hope the entire series or this course material that I'll provide for you will be a great head start in your machine learning journey. Okay, so I'll end this video now, and I hope to see you guys very soon. Thank you.